Hello guys, my name is Aman and this is my first video on this channel. So we are going to start the series of complex number. So what is complex number? To understand complex number, we first need to see number system. Now we know that number system is divided into two groups, real and imaginary, real numbers and imaginary numbers. Real number consists of whole numbers, natural number, rational number, irrational number, integers, negative values, and many more things. An imaginary number consists of pi, p, iota, alpha, beta, gamma, delta, epsilon, etc. etc. So, in this chapter, complex number, we have to use this iota. This I is called as iota. It's iota. Value of iota is under root minus 1. Now iota is something which was introduced by Euler. Euler was a very known popular mathematician. So let's start with the basic. So the basic form of a complex number is a plus b iota, where a is a real number and b iota is an imaginary number. So this is the basic form of a complex number. So as I told, iota is equals to under root minus 1. Value of iota is fixed, is never going to change. And iota square will get under root minus 1 times under root minus 1, which is minus 1. Iota cube, it will be under root minus 1 times under root minus 1 times under root minus 1 is equals to minus iota. If we solve it, we get minus iota, and iota raised to the power 4 is, as we know that iota square is minus 1, so iota raised to the power 4 will be minus 1 whole square, which is equals to 1. So iota is equals to under root minus 1, iota square will be equals to negative 1, iota cube will be negative iota, and iota raised to the power 4 will be 1. So what about iota raised to the power 80? Seems difficult, but not. Answer is 1. How? This is 80. Exponent is 80. If the given exponent have the factor of 4, as we know that iota raised to the power 4 is 1. So any exponent which have the factor as 4, then answer is going to 1. Like iota raised to the power 40. Again 40 have the factor of 4. 4 tens are 40. So answer is 1. Iota raised to the power 24. Again 24 have a factor of 4. So 1. So like this. Like iota raised to the power 120. Again 1. Because 120 have factor of 4. So now what about iota raised to the power 82? Now we know that iota raised to the power 4 is 1. So we can write iota raised to the power 82 as iota with the exponent of factor as 4, means iota raised to the power 80 times iota raised to the power 2, means iota raised to the power 80 times iota square is iota raised to the power 82. So iota raised to the power 80 has a factor of 4, yes, so this is 1, and iota square as you saw here is negative 1, so it will be times negative 1, so answer will be negative 1. So iota raised to the power 82 will be negative 1. Let's try one more, like iota raised to the power 25. We can write it as iota raised to the power 24, which has the factor of 4 times iota. Now iota raised to the power 24 will get 1 times iota is under root minus 1. So answer is under root minus 1, or we can write it as iota. So till now it's clear. So what about addition of complex number? Suppose we have to add 2, let me write here, okay, so 2 plus 3 iota plus 3 plus 2 iota. How to add them? So it's pretty simple to do it, like 2 plus 3 iota plus 3 plus 2 iota. Here real values are 2 and 3. These are the real value, and this 3 iota and 2 iota, these both values are imaginary. 2 and 3 are real, 3 iota and 2 iota are imaginary. You can further do it like addition of real values plus addition of imaginary values. So 3 plus 2 will be 5 plus 5 iota. So you can further do it like taking 5 common, 5 plus iota. Remember one thing, we cannot add an imaginary number to a real number because they both are different. Let's take one more example. 7 plus 9 iota plus 3 plus 8 iota. So it's again very easy to do. 7 plus 9 iota plus 3 iota plus 8 iota. Again the real values are 7 and 3. So adding real values and imaginary values, 7 plus 3 will be 10 plus 9 iota plus 8 iota will be 17 iota. So this is our answer. This is about addition. What about difference, subtracting? It's again very easy. Like let's take the same example, but this time a negative sign. So in this case, here we get the negative sign. You can write 2 plus 3 iota as it is, and this negative sign is multiplying 3 and plus 2 iota. So 3 has the sign as plus, so plus into minus is minus, so it will get minus 3, and again plus minus minus 2 iota. So it's now easy to do. 2 minus 3 iota plus 3 iota minus 2 iota, it's minus 1 plus iota. So we can write it as negative 1 1 minus iota. Both the answers are correct. So this was about subtracting. What about multiplication? Let's see it. 2 plus 3 iota times 7 plus 2 iota. So 2 is getting multiplied in 7 plus 2 iota. Then we are going to add 3 iota multiplying 7 plus 2 iota. Like first we will write here 2 multiplying 7 plus 2 iota, and then is plus sign between 2 and 3 iota. So 3 iota getting multiplied to, it's very basic, everyone knows this. It's 14 plus 2 2s are 4 iota plus 7 3s are 21 iota plus 3 2s are 6 iota square, because iota times iota is iota square. So let's simplify it. It will get 25 iota plus 6 iota square. Value of iota square was minus 1. So it will get 14 plus 25 iota, here it get negative 6. So 14 minus 6 plus 25 iota is 8 plus 25 iota. This is the solution. Let's take one more example, like 4 plus 3 iota whole square. It's very easy, like 4 plus 3 iota times 4 plus 3 iota. Again the same step, 4 multiplying 4 plus 3 iota, then plus 3 iota times 4 plus 3 iota. 4 fours are 16, 4 threes are 12 iota, 4 threes are again 12 iota, plus 9 iota square. It will get 16 plus 24 iota, and it will get minus 9. 16 minus 9 plus 24 iota will get 7 plus 24 iota as our answer. So it's pretty simple to add, subtract and multiply. But what about division? We'll learn it in further parts. But for now, this is all that we have to do. So let's take some example. Let's take under root negative 16 plus 3 under root negative 25 plus under root negative 36 minus under root minus 625. So we have to evaluate. So what to do? Again, like we write root 4 negative 4 as root 4 times root under root minus 1, then root 4, and this under root minus 1 is nothing but iota, so it will get under root 4 iota. Under root 4 is 2, and 2 times iota is 2 iota. So root under root 16 can be written as 16 times under root 1 plus 3. It's getting multiplied in root 25. So root negative 25 can be written as root 25 times negative under root plus 30. Negative 36 under root can be written as under root 36 times under root minus 1 minus 625 times under root minus 1. So now we just have to replace under root minus 1 with iota, right? Root 16 under root minus 1 will get iota, plus 3 is getting multiplied. Root 25 under root minus 1 will get iota, plus root 36 under root minus 1 again iota, then 625 iota. So root 16 is 4, so it will get 4 iota, plus 3 times root 25 is 5 iota, plus 36 iota. Root 36 is 6, so it's 6 iota, minus root 625 is 25, so it will get 25 iota. So 4 iota, so 3 is getting multiplied in 5 iota, so it will get, so we will get 15 iota plus 6 iota minus 25 iota. We will get 25 iota minus 25 iota, will get the solution as 0. So let's take one more example. 4 under root, let's name it second, 4 under root negative 4 plus 5 under root negative 9 minus 3 under root negative 16. This is all. So again 4 is getting multiplied, so root 4 times under root minus 1 plus 5 is getting multiplied, root 9 times under root minus 1 minus 3 again getting multiplied, root 16 times under root minus 1. So 4 still getting multiplied. Root 4 will get 2, under root minus 1 will get iota, plus 5 is multiplying. Root 9 will get 3, under root minus 1 will iota, minus 3 again in multiply. Root 16 will 4 and under root minus 1 iota. So now just simplifying, 4 2s are 8 iota plus 5 3s are 15 iota minus 12 iota. We'll get 11 iota as our solution. So multiplication and addition subtraction is pretty simple to do it. So now let's move to how to find the tangent or polar form of a complex number. So for that, you first need to draw a graph. Let me name it. It's x-axis, x-axis, y-axis, y-axis. So everyone knows that x and x are positive and y are negative. So this is the first quadrant. This is first quadrant, the second, third and fourth. The first quadrant is plus plus because the both axes are of positive, so it will plus and plus. This is second quadrant. Here y-axis is negative and x-axis is positive, so it is minus plus quadrant. The third quadrant, first, second, third. This is third. Both the axes are negative, so it is negative and negative. And here it's the last one. Here one value means one axis is positive and one is negative, so it is like this. So what to do with it? If it's first quadrant, then theta is always equals to alpha. Now what is this theta then? We'll get to know in further. In the second quadrant, theta is equals to pi minus alpha. And here in third quadrant, theta is equals to alpha minus pi, and in fourth, theta is equals to minus alpha. This is what we need to learn. Remember this as formulas or something like that. So now we are going to solve some question related to this. So by solving, we get to know like what is the use of this theta and this all quadrants. So before moving further, let's take an example of division of complex number. Division is also easy. So how to divide it? So everyone knows the method of rationalizing the denominator. Like we have 1 plus under root 2 upon 1 minus under root 2. We just change the sign of denominator and multiply it in numerator, like multiply by 1 plus under root 2, multiplying the same in denominator, we'll get 1 plus under root 2 whole squared upon 1 square minus under root 2 square. Then we'll simplify it like 1 plus 2 under root 2 plus 2 is 3 plus 2 under root 2 upon 1 minus 2. It will negative 3 plus 2 under root 2. We do it like this. So here we have to do the same. So first we are able to notice here iota is common out there. So let's first multiply it. Iota times 4 is 4 iota. 3 iota square. 3 iota square. So 3 iota square will be 3 minus 1. So it will get 4 iota minus 3. And our basic form was a plus b iota. you can write it as a real number first, then an imaginary number upon 1 minus iota is going on. So like a rationalizing denominator method, we just have to change the sign of this imaginary number. We have to change the sign of imaginary number. So in this method, we name this method as rationalizing denominator, but in this we call it as conjugate. So if we have, let's take it here. Okay, so we have suppose 1 minus iota, so it will get 1 plus iota. So we can say that 1 plus iota is conjugate of 1 minus iota. 2 plus 3 iota, conjugate of it will be 2 minus 3 iota. 7 plus 8 iota, conjugate of it will be 7 minus 8 iota. Just changing the sign between them is what conjugate of it. So now I think that our concept of conjugate is clear. So we just have to do the same, like multiplying it with the conjugate. Conjugate of 1 minus iota is 1 plus iota. 1 plus iota upon 1 minus iota, again multiplying by 1 plus iota. So it's basic multiplication that we learned before. It's negative 3 times 1 plus iota plus 4 iota times 1 plus iota. So it will get negative 3, sorry, we will get here negative sign, negative 3 iota plus 4 iota plus 4 iota square. So negative 3 plus iota minus 3 iota plus 4 iota will get 1 iota, which is iota, plus 4 of negative, because it's iota square and iota square is minus 1. So minus 3 and this minus 4 plus iota, right, minus 7 plus iota. Now we have to solve the denominator. Denominator is 1 minus iota times 1 plus iota. So now by looking at this, we remember a theorem like a square minus b square is equals to a minus b, a plus b. So it is in the form of this. So we can write 1 minus iota times 1 plus iota as 1 square minus iota square. 1 square is 1 minus iota square. Now 1 minus iota square is negative 1. So negative times negative will get positive and we'll get the value as 2. So minus 7 plus iota is numerator and our denominator will be 2. So the value means now we have to convert this into our basic form a plus b iota. So our a will be negative 7 upon 2 plus iota upon 2 or 1 iota upon 2. So this is our solution for this. Let's take one more example. Say 2 plus iota upon 3. Let's take 3 minus iota and then 1 plus 2 iota. So if we multiply 3 minus iota to 1 plus 2 iota, we'll get 3 1 plus 2 iota minus iota 1 plus 2 iota. 3 1s are 3, 3 2s are 6 iota minus iota minus 2 iota square. 3 plus 5 iota minus 2 minus 1 will get 3 plus 2 plus 5 iota, because negative 2 times negative 1 is positive 2, because negative into negative is positive. So 3 plus 2 will get 5 plus 5 iota. So our denominator is 5 plus 5 iota. So 2 plus iota upon 5 plus 5 iota. So again, by multiplying numerator and denominator by conjugate of denominator. So conjugate of denominator will be 5 minus 5 iota. So 5 minus 5 iota. Denominator is also getting multiplied. Yes. So 2 5 minus 5 iota plus iota 5 minus 5 iota. It's simple multiplication. 5 2s are 10 minus 10 iota plus 5 iota minus 5 iota square. So 10 minus 5 iota minus 5 minus 1, it's 10 plus 5 minus 5 iota, it's 15 minus 5 iota. 15 minus 5 iota is our denominator. Again, our denominator is something like a minus b and a plus b. So we can write it as a square minus b square. A square is 5 square minus b square is 5 iota square. So 5 square is 25 minus 5 iota square. We get 25 iota square. So 25 minus 25 iota square will be negative 1. So it will get 25 plus 25 will get 50. We'll get the denominator as 50. So 15 minus 5 iota upon 50. So if we take 5 common out here, we'll get 3 minus iota upon 50. So now we can cut 5 ones are 5, 5 tens are 50. So we can write it as 3 minus iota upon 10. So in basic form we'll write it as 3 upon 10 minus 1 upon 10 iota. So this is our solution. So for today we'll stop here. So now we will see the polar form, the tangent, the module, and second part of the video, and we will solve many examples like this of conjugate in second part. So see ya, bye bye.